Hello, everybody. This is the weekly Gateway API meeting. Today is July 2nd. And yeah, this meeting is regulated by the CNCF Code of Conduct. So please be nice to each other. And in the meantime, if you want to write down your names in the document that we have in the meeting notes here, it would be great. And yeah, I don't know if anyone else, if anybody here is new to this kind of meeting. If you want to introduce yourself, say a few words about yourself, or otherwise we can start.
Maybe I can start. First time for me. I'm the creator of Traffic, open source reverse proxy, and currently the CTO of Traffic Labs, the company behind it. Nice to meet you all.
Yeah, great. Nice to meet you.
All right, I guess I could go next. I'm Shalansya. I'm from Pakistan. I work for a company fintech called Wahid, essentially, and I'm just trying to explore the network API, essentially in Kubernetes, and trying to make sense of things and hopefully they contribute to it as well. So yeah, I will know.
Hey, welcome. Anyone else? Okay, I guess we can start from the first item. This one is from you, Guy. I think you have a nice demo on policy machinery. So yeah, stage is yours.
Thanks, Mattia. So as some of you know, I am a member of the Quadrant team at Red Hat, where we are doing extensions to Gateway API implementations based on policies and also leveraging policies. So we have 4 kinds of policies. We have DNS policy, TLS policy, auth policy, and rate limit policy. And we either support or want to support for our policies to be able to target at least 2 kinds of Gateway API resources, gateway and HTTP routes, plus the section names in between, right? So talking about the listeners of gateways and the HTTP route rows. So I added this topic to the agenda today to share a little bit about our approach for calculating effective policies, right? So this is not meant to be a proposal or anything. It's really just us sharing the direction we are heading at this approach for calculating the effective policies. Right. So this is a conversation that actually got traction a while ago, and I think it was at KubeCon in Paris when we shared Quadrant's plans for implementing defaults and overrides. I don't know if I can share my screen. Let me see if I can.
Yeah, you should be able to.
So I'm gonna take it over, okay?
Okay. Yeah, sure.
Okay, and share. Yeah. So I was talking about, the Quadrant's plans for defaults and overrides, which is summarized in this document here, this IFC. I think if I do not have the link in the agenda, I'll make sure to do that. Which was, to sum up, was basically about our 4 strategies for merging policies together, right?
Oh, yeah.
So those are the ones that you can see in the document referred to as atomic defaults, atomic overrides, and also the more granular strategic merges between policy specs at the level of each individual policy rule inside of the policy spec. So those are the 4 kinds of merge strategies that we support in Quadrant: atomic defaults, atomic overrides, strategic merge defaults, and strategic merge overrides. In this document, we also find some reference to other features of our merge strategies, such as the concept of constraints and uncertain defaults, but you can disregard that for the moment because they're not really important for the conversation today. And the current state we are on this is we're currently working on the implementation of the strategic merge defaults and strategic merge overrides for our kinds of policies. And we already have the atomic defaults and atomic overrides implemented. We're also still refining those other features that I mentioned before, constraints and unset. But basically, I think most people remember that conversation when you see some of the examples of those different merge strategies that I mentioned here, right? In the document, you find these examples, usually of two policies being merged together. I think almost all the examples we have on your left-hand side, a policy that targets a gateway. On the right-hand side, you have a policy targeting an HP route, and then we merge those two. And the third one is actually the expected effective policy for all the four merge strategies that we have, right? For example, this one is a use case of a default, atomic default. So last week I decided to kick off this project here, policy machinery, where we're bringing all the tooling that we use for implementing those merge strategies, current and future, right? And I'm jumping now to my Visual Studio Code here, because I think probably the best way to demo this is by showing the code directly, right? So in that repo, you will find a set of examples here, including the examples of the quadrant merge strategies here, right? So the thing that you see on those diagrams of two policies being merged together, you also find represented here in this test cases here in Golang. Maybe I could have represented this some other way, but hopefully you will find with reading, Golang code. And I honestly recommend, checking out this repo by going directly to the test files. So here we have a few test cases for all those four merge strategies multiplied by the different scenarios, including like trivial scenarios of two policies being merged, where one policy defines rules, another one's an empty policy, two policies containing rules without having any conflict between those policy specs, and then two policies with conflicts between those policy specs, right? This is for an abstract kind of policy called color policy, right? Where the semantics here is basically you have a source policy that is merged into a target one, right? And by the way, target, not to be confused with the target as in the object that is targeted by this policy, right? So, but this is basically the same thing that you have in that RFC. So this is just translated into Golang code. The two policies apply the given strategy and the expected outcome that you have, right? You can execute this and you see that this is what you would get, for example, in the case of default atomic merge strategy, right? If you scroll here further down, you'll find atomic overrides and similarly to all the other kinds of merge strategies that we have. So this is one bit that I wanted to share. But this is no different from the thing that I said that you find in the document in the form of text or those diagrams, right? We actually needed something to model for more complex topologies and more complex scenarios. So this is something that we needed. And by complex topologies, I mean things like this being effective policy being calculated on top of topologies that include things such as multiple gateway parents of a route, parent reps with and without section names, backend reps with and without port numbers, and policies targeting at different levels in the hierarchy with and or without section names, plus combinations of all those merge strategies. Okay, so hence the other part of this repo here, right? So we have one part with the examples of the policies and the merge strategies. And the other concept that you will find here in this repo is the concept of a topology, right? So back to the README of the repo, what you can do here is you can create a new topology, which is basically a graph, right? Where you add nodes of typically two kinds. One is a targetable and another one is policy, right? The graph is more generic than that. It's actually a graph where you can append objects in general. An object is an interface from which we derive those two more specific other interfaces called targetable and policies. And because it is a very generic data structure, you also need to teach it how the targetable, how to relate the targetables. Yeah, go ahead, Rob.
Yeah, just a really quick question. I was looking at this. One, this is very cool. But just while I've been thinking about this, is there a way to limit which policies can target which targetables? Or is it every policy in this list targets every targetable?
This is another layer, right? So in this idea, there's no validation on the policy. So this is up for the specification of your policy CRD and how you validate the policy CRs. So in the policy CRs, if you allow targeting, let's say gateways, then you get policy instances that in the target graph will have a gateway in the kind of the target graph, right? So what this does is whatever it finds in the target graph, it will build the relationship with the targetable resources. So we're calling here targetables. Maybe this is a bit of an overstatement. Actually, it's only targetable what you allow to be targeted according to your policy specification, right? But for the purpose of building a topology, any object that is not a policy is a targetable object, right? So the idea is only to model the relationship between the network resources, right? In a very generic way. So generic that here we're calling targetables and we are passing a list of gateways, then a list of HTTP routes, a list of services, and we are using these helper functions here that are that teach how to link, for example, gateway resources to HTTP route resources. If you check the implementation of this function, obviously it's using the parent ref field in the HTTP route, to find the gateways, and that's how it builds the links between gateways and HTTP routes. I'm going to speed up here, and obviously we also have a helper for this in case you want to use this topology struct to build gateway API topologies, right? So for gateway API topologies, there are known kind of resources. We have this helper function that you can build a gateway API topology where you actually pass as targetables gateways, HTTP routes, and services, and you don't need to teach anymore how to link those kind of resources because this is part of the abstraction. The abstraction already knows how to link those kinds of resources, right? Again, let me jump to a test case because I think this is easier to understand if you have a test case in front of you. So this is a test case for building a topology, right? So here I have multiple test cases. I'm just iterating over my test cases. Hopefully you can see this. I don't know if it's too small. You let me know. So
it's okay.
Thanks. So for each test case, we're building a topology, right? As you can see, here is a topology of fruit objects. So we have three different kinds of fruits. We have apples, oranges, and bananas. And we have helper functions that teach the topology how to link, in this case, apples to oranges and oranges to bananas, right? So if you actually inspect, the spec of an apple resource, you will see that it only has a name. An orange has name, namespace, a list of apple parent, a list of child bananas, right? And again, banana is just a name. Okay, and this will allow us to build topologies from the most trivial one that has no nodes, single node, topologies with multiple group version kinds, right? Such as this one where you have different multiple apples, multiple oranges, one policy, it's a fruit policy, and even more complex ones, right? Such as this one. I'm here in this test case, basically building the topology that is described here in the form of this set of objects. Then I'm just asserting for the links. So this is a test case to make sure that we are building the right links as expected. And I'm also putting this in the form of a dot language file so we can actually visualize this topology better here. So when you run this test case, it's going to output this here in the, let me put this. So this is, for example, the test fruit topology for the more complex one that we have. Hopefully you can see this here on the screen, right? So we're adding apples, oranges, bananas, and we are adding fruit policies instances, right? And the link functions teach how to link those types of objects. And from the target graph and the definition of the target graph for the fruit policy kind, we infer also the relationship with the different objects. As you can see in this example here, the fruit policy can target at least apple resources and orange resources, right? Well, if you can use this to model a topology of fruit objects, hopefully you can also use it to model topology of gateway API resources, right? So of course, we also have test cases for building topology of gateway API resources similarly, right? So this is another test case that uses that helper function further down here, I guess. Yeah, topology. Oh, yeah, I have two versions of it. I have topology without section name, and I have the same thing with section name here. And this one is using the helper. So it builds a new gateway API topology. It passes a list of gateway classes, gateways. There's this option to expand from the gateways, also the listeners within the gateways as targetables themselves, right? And this other test case here on the top is a simpler one without section names. So this one I'm using the base topology, but I could be using the abstraction here as well, just the same. So I'm adding gateway classes, gateway routes, and I'm only using the links between gateways and routes without, you know, the sections in the middle. Jumping straight to the topology that this test case will generate, this can allows us to generate topologies such as this one. So for example, gateway API topology, one of each kind. This is, yeah, better this way. So this is for a relatively simple topology where you have gateway class, gateway, and HP route and service, and a policy is targeting the service. When I say complex topologies, one of the things that we learn from complex topologies, one dimension of complexity here is the one that we get from the section names, right? So this very same topology here, and back to the test case. So this is the complex topology, right? Where I'm activating a test helper function here that is building this topology here that is here on the screen. Two gateway classes, multiple gateways, multiple routes. Sorry, I was showing this one before. One of each kind. One of each kind is this one here. One gateway class, one gateway, one route, one service. This very same topology on the other test case.
So this is incredibly cool, but I do want to add a time check here because we have a lot of things to get through in this meeting. I see a couple questions. Maybe we can get to them and then move on. If you can wrap up soon.
Absolutely, yeah, you're totally right. So just to jump here to comparing this to the same thing with section names, this becomes this, right? Where imagine if a test policy could be targeting not only service, but maybe also gateways, maybe listeners within the gateways, maybe HP route within the HP route rules, maybe service ports, right? Because of the section name. And to show it's slightly more complex than this, right? This would be an example of a very complex topology. Two gateway classes, multiple gateways, multiple HP routes. And the same thing with section name.
I really, really like the fact that you've gotten a tool that can construct these topologies in reproducible ways. And at the same time, it makes me immensely sad to realize that there are people who are going to be doing things this complex and more in the real world.
Yeah.
So thank you for building the tool. This is going to be really, really useful for testing, I think.
Once you have a topology, thing you can do with this is you can, for any given node, you can ask for the parents, for the children of this node. You can get for all the path between two nodes. And obviously for each targetable resource here, you can get the list of policies. And if you have a path between two nodes, you can build from the bottom up, get all the policies in that path, and you can compute the affected policies by applying a given merge strategy. So that's what we're going to use this for. For example, here in between gateway and this HP route, you have at least two different paths that lead traffic to that, right? So path can go through this listener here or through this listener here. Maybe we have policies attached to any of these levels here. So I can get like any, for all the path between those two resources, I can get all the list of policies, and I can iterate through those policies and compute the effective policy. And this is basically what I'm doing here in this test case that I will leave, for reference based on quadrants for merge strategies, right? So we have a slightly simpler topology, gateway, 2 routes, multiple route rules, and we have policies attached to all those levels. And we are basically computing the effective policy for each pair of gateway and HP route rule, giving us 4 different paths, in this case, 4 different effective policies. And what we're going to do is we're going to use this to configure our services that enforce our policy decision point that enforce those policies, and configuring the gateway to activate those exact effective policies when there is a request that matches that particular path. So this is what we had. I'm sorry I took too long. I was expecting to take like 15 to 20 minutes, but I wanted to share this.
No, no worries. We really appreciate you sharing.
Yeah, I believe this is it's another iteration on that conversation we started back in Paris, and I think this is obviously comparable to something that we also have in Gateway Kernel, right? Which also computes effective policies, with some noticeable differences I would like to list very quickly here. One, that this is for any custom merge strategies, right? Unlike the one that we have in Gateway Kernel, that is only the JSON patch merge strategy, which, by the way, I also left here as another example. So you could also implement the color policy following the JSON patch merge strategy instead of quadrants, right? Another one is that this comes with a very generic and flexible topology data structure that allows to model for other applications beyond Gateway API, right? If you think on how could you use this for like ingress or anything, you could also use that, right? It's very generic. If you can use for fruits, you can use for anything. You can also use this for tailor-made Gateway API topologies where you don't need all those levels. Maybe you don't need gateway class. Maybe you don't need service. One thing is in the middle. You can also build your own tailor-made topology only for those kinds of resources. This makes it very easy to also add new kinds of Gateway API resources. I only here have HTTP route, but it's literally a 5-minute job to add gRPC route, for example, right? And plus, there is no difference between direct policy and inherit policy in this implementation that doesn't come from the definition of a merge strategy itself, right? That's also something that we discussed in the past. So basically, the no merge strategy, which also happens to be the default merge strategy, defines the concept of that we currently know as a direct policy.
I'm going to jump in and be the bad guy to point out that Lior has had his hand up for a while, and we are almost half an hour into this.
Appreciate you. Yeah, well, that's great, Guy. Just a quick question. So if I just go back to the simple example with the one of for each kind, so when you have arrow from the policy to the type, does that mean that it is direct attachment?
No, not necessarily, right? The concept of direct or inherited here depends on the merge strategy that is implemented by this test policy. So this is just a data structure that you can navigate, and then you can use that to apply your merge strategy. What's going to tell if this is direct or an inherited, it's how you apply your merge strategy. For example, if you want to get all the policies in a given path and start up merging them together, then it's inherited. If you're only interested in the policy attached to the service directly, then it's a direct policy.
1 second, but so the tool that you kind of demoing right now, right, outputs this, right? Let's say I have.
Well, I can. This is basically being generated by the test cases here, right?
I understand, but I'm saying like this is what let's say I'm a user, right, and I'm running this tool, and that's going to be my output, right? I'm going to look at this. Let's say I have an environment, live environment, and then I'm going to look at this, right? Let's say the environment is the exact environment. So now I want to understand, let's say I see the test policy reference this service, but I want to understand, okay, maybe I don't want it to be like, maybe I want to remove it. So ideally, it would be nice if we can differentiate the arrows, say, all right, is this direct policy? So now I can go to this policy and remove the reference, or if it's something else, then I might need to do something more complex to understand how this service gets into this policy. Does that make sense?
It does make sense, right? The way we're actually using this today is like this. So we build a topology, and for this topology, for example, this one here, we have multiple test cases here, right? So let's say we build a topology that contains gateways, HP routes, services, policies. In this case, I'm not interested in gateway listeners. I'm only interested in gateways, HP routes, and HP route rules and services. And then I have policies attached to any of those resources, kind of resources. So what I do here is, this is for my application, right? For Quadrant application. So what I do is I get every pair of HP route and gateway. I only have one gateway in this example, so this allows me to do this, right? So for each one of those, for every path that I find between this gateway and each of HP route rule, I gather all the policies that I have in that path. And in my application, I know I can start just merging those policies together, right? Because my policies are inherited policies. And this is given because I'm doing this, and because of the merge strategy that my policy implements, basically merges one policy into the other. The default merge strategy would be just deciding on the target policy and not doing any merge at all. That would be a direct policy. If you need more than that, for example, if in your policy, you also need some kind of label that would specify this is a direct policy, so don't even try merging because this is pointless, you could do that, right? And you could have an if condition here that just skip the part of reducing here, my list of policies by merging them all into one single effective policy.
Okay.
Cool. This is awesome. I think we should call it at this point, but this has been incredibly interesting. I'll follow up offline myself because I have some follow-up questions too, but want to leave time for the remaining. I think the agenda has only expanded since this meeting started, so I want to leave room for everyone else as well. But thank you.
As is the nature of agendas.
Yes, I am very, very excited to play with this more. Great demo.
Yeah, thank you, Guy. Candace, it's your time.
Thank you. So I added this to the agenda to talk about the gateway merging PR. Wonder if we could use the policy machinery on gateway merging. So we have this long pull request. Takes a long time to read through it all. But in the end, I think that the question that I have is, what are we going to do with this? Is this coming back again? I'd like to see some kind of resolution, but mostly, so standard mechanism to merge multiple gateways. So for anyone who isn't aware of the problem with merging gateways, we have a few different implementations of Gateway API that combine, I'm going to put it this way, let me know if I'm wrong, anybody, combine the traffic for different components by merging different pieces of Gateway API. So in this case, if there are multiple gateways, like that say have the same listeners, or, just where the traffic would end up at the same destination through those different gateways, then those two paths could be considered to be merged. So so merging an entire gateway, sometimes the merge happens on just one listener within that gateway. Sometimes I guess the merge, mostly what we're talking about is the merging of a traffic path when we're talking about this. So, and it's virtual. It's not, it happens within the implementation, whereas the traffic destined for a certain shared destination is routed through the same mechanism. You don't have duplicate mechanisms for the same endpoint destination. Okay. So
Candace, can I interrupt very quickly to ask, do we believe that the GEP in the PR accurately reflects all of the commentary in the PR at this point? Or do we believe that
No.
it's important to actually read all of the commentary instead of just the GEP?
I think Dave, it's your PR, it's your GEP. Dave was waiting for, some conclusion on the commentary. I guess. So, and for
Dave?
some interest maybe also in this topic. And I just wanted to express that we are interested in it for a couple of different reasons. And that there are still some pieces missing, like the actual standard mechanism and the rules for combining things. But if in the end we don't end up having something like that, because it's impossible for different implementations to agree on how to merge these traffic paths, then we should say, it's implementation dependent in the end.
Rob?
For what it's worth, I'm gonna spend this
Oh.
week kind of addressing the comments, and actually, I was waiting for Maintainer to add some commentary, and then I think I got that 2 weeks ago. So
Yeah, I think at least myself and Nick have added comments recently. Sorry. What I would say is this is, to Candace's first question, this GEP is one that did make scoping for 1.2. So we are going to take every effort we can to get it in for 1.2. With that said, this is one of the ones that makes me the most nervous of all, because we're basically talking about adding another layer of hierarchy to Gateway API, right? This proposal adds this concept of parent and child gateways, which, although at least in the GEP as it's proposed today, is the same thing, the same resource, but it is still adding hierarchy. I added a question to just start a rabbit hole of, does gateway merging even mean that TLS route becomes unnecessary, right? And I think these are the kinds of questions we should be asking and hopefully answering with this GEP. Sorry. So basically, if we can, yeah, right. So if we, Mattia and I think Candace had been working or thinking about TLS route and maybe moving that forward in 1.2 as well. So I would just ask that people working on TLS route and people working on gateway merging get together and think about these questions. I'm not sure that, one necessarily obviates the other, but the further down we got, I was chatting with Nick some, I don't know, 12 hours ago. And if you go to the bottom of this thread, I started yet another rabbit hole of, maybe what we actually, and there's more discussion since then. Great. Okay. Like maybe if we had gateway merging, what we actually need is like proper delegation with like different resources for like add a new thing that is a parent gateway or a new thing that is a child gateway. I don't know. And maybe that makes TLS route much easier to represent via a gateway. I'm not sure yet, but I just feel like since we're adding another layer of hierarchy, we should consider anything on the table and get a bit creative here. Yeah, those are my thoughts, but I am very happy if there's interest in kind of a one-off brainstorming meeting for this. I'd be happy to see this move forward. But a reminder that we're less than 4 weeks away now from when we're expecting any GEP in 1.2 to be merged as implementable. And given the complexity of this one, I think that puts this one at risk, and we need to do everything we can to get it moving.
Everything you're saying makes me think that we should be seriously questioning whether adding yet another layer of hierarchy is a good idea.
Yeah, absolutely. I agree. So
with absolutely no disrespect to David for an obviously well thought out proposal that fits nicely with an actual use case. Yeah, this is kind of terrifying. Sorry, Dave.
That's
yeah,
fine.
and
Then
these
add the comments to the GEP, right? Like
No.
this GEP's been open
Yeah,
for over a year, so
yeah,
like
and
getting feedback would be useful before I do edits and put time into it.
Yeah, so Dave, would you recommend that I go over the comments individually, or would you recommend that I read the GEP in its current state just to try to get myself back up to speed?
I would say read the GEP in the current state, and I think the last time I revisited it was maybe when Rob did his initial round of comments a few months ago.
Okay.
So that might be a good reference point. And then if the hierarchy is like a deal breaker, then that would be good to know right away. I don't know if
so
it's like
to clarify, I'm not necessarily saying that's the wrong way to do gateway merging. You know, what I do want to call out is it seems like the majority of implementations, not the one I work on, but the majority of implementations do some form of gateway merging, right? It's kind of automatic, or there's different forms. I think Envoy Gateway, it's a parameter in gateway class. Arco, correct me if I'm wrong on that one.
Yeah, that's right.
I forget. Okay, yeah. So there's different approaches already out there. I definitely think we should work towards some form of standardization at a minimum, you know, recognizing that, say, 90% of implementations are doing something resembling merging today. But this idea of hierarchy, I think this idea of hierarchy was particularly useful for adding a large number of listeners and particularly generated listeners, right? That was the key value of hierarchy as opposed to just flat merging. Is that fair?
yeah, I think so.
Okay. All right.
And
well,
you could maybe caveat with the condition that like the earlier opinion was we don't want to introduce a new resource for listeners.
Yeah. Yeah, I think, you know, my gut here is that if we really want to move forward on this, we may need a dedicated brainstorming meeting for the people that are interested in moving this and probably TLS route together. Not saying they end up being the same thing, but there's a lot of overlap in the discussion right now.
Yeah, even because if I remember your discussion here, Rob, basically the TLDR is if we go with the hierarchical approach of merging gateways, we don't need TLS route at all. I mean, we can just use gateway merging plus TCP route, and that's it, right? So
yeah,
I think that also before spending too much time in the TLS route, that could be a waste of time, basically, probably we should address this concern beforehand.
Contrarily, I disagree. And I would urge people to take a look at this 3177 PR that Rob posted, and what the sorry, I couldn't see who was talking, but the previous person had mentioned. The answer is yes. I would say the answer is you know, not yes. It's more like a maybe. But I don't see a lot of people. To me, I may be biased, but it looks like it's more sort of a 50-50 split as
Yeah.
to, yeah.
I
So,
agree.
and so maybe some more people could make a comment on this. My request was that we could separate this from either separate gateway merging from TLS route, or choose one to go into one version 1.2 rather than both to go into version 1.2. there's a lot of work to be done, especially if we make TLS route unnecessary. I think I agree with one of the comments in here that says TLS. So gateways are at a level for cluster admins to be working on. TLS route is at a level more for application developers to access. So keeping those things distinct and separate is more in the spirit of Gateway API than to combine those things.
I have a lot of thoughts here, but I think maybe they're better spent on a more dedicated discussion for this. So I will hold off on them because I know there's more on the agenda still. But yes, this is a big topic, and I am increasingly convinced a one-off meeting just to dive deep into that would be helpful. Yeah,
You can,
I can.
Please invite me.
Yeah,
I'd come to it.
For sure. I will either work on scheduling that or find somebody who can. But yeah.
And just to conclude this topic, the use case that we have is actually related to creating DNS records, and we'd like to try to resolve this in terms of whether we need to create DNS records based on gateway merging, whether we ignore gateway merging when we create DNS records. And we're not exactly sure what we're going to do with this yet, but the way that traffic paths are merged will have a lot to do with
Is there a discussion
how we work out DNS?
Is there a discussion somewhere about external DNS on host names in X routes? Like, is there
I don't
something
think
written
so.
down on that one?
I mean, external DNS has their own documentation, but I don't think we have anything in Gateway API about that.
We do have an open issue asking for resolution, a little bit more resolution on DNS, because actually Quadrant has its own DNS solution as well. I'm not sure if GE works on that part of it. I don't work on Quadrant, even though this is contained
Is that related
under
to their multi-cluster stuff?
Yeah, I confess to being a little
Yes,
surprised
think so.
that host names in a route would be used to create records in DNS, because I always think of host names in a route solely as a header match, basically, as a filtering mechanism, not a global configuration mechanism. So I'm very interested to see
I can
what
find
I can
a
find out
reference.
about the rationale about,
I can try to find a reference before the meeting's over, but I just read about that last a few days ago, so
that's fascinating.
It's another rabbit hole. So I'm satisfied with closing out this and talking about it again another time. So if we want to move on to another item in the agenda.
I think Guillermo has a question.
Yeah.
No, it wasn't a question. So I just lowered my hand. I will just to say that I do not work on that part, even though, but nevertheless, I can say that Quadrant's reconciles DNS records from the gateway listeners. It does not consider the host names in the HP route.
Makes sense.
Makes sense.
Cool. Yeah, we should keep moving. And the next one is mine. So as I mentioned earlier, 1.2 gaps need to be merged as implementable by July 30. That is 4 weeks or less away from today. Otherwise, they're going to be dropped from the 1.2 scope. I cannot emphasize enough that review bandwidth is going to be limited the closer we get to that date. So don't just assume that if you have something in by July 28, that we're going to get it reviewed and approved by that. It's just unlikely. So please, please, please have GEPs available sooner than later. I do want to specifically call out 2 GEPs that came in recently for the 1.2 scope. The first one is percentage-based request mirroring. Maybe, Mattia, if you can open this one up real quick, I can give a quick overview of this one. This came from Jake, who's on Google's load balancing team. I think this is a very straightforward one. I'm obviously biased, but this is just adding a percentage field to request mirror filter. And specifically, the recommendation is to use a fraction. So if you go up a little bit, it's a little funny, but this percentage type, yeah, there's a fraction struct. So there's a numerator that has a value and a denominator which defaults to 100. So most people, if you're just trying to put a normal percent, get to choose a whole number. If you want something that is more precise than that, you need to change the denominator. This is all a painful way to work around Kubernetes API conventions that floats should not be used because they can't be round tripped because yay.
Because floats suck. But
yes,
has
exactly.
anybody actually demonstrated a use case in which an integer number ranging from 0 to 100 is insufficient and you really need the denominator?
Yes. So it's basically the very
Sorry,
high
traffic. Okay, go ahead.
Yeah, it's basically the very, very high traffic customers that want to sample a very small portion of their traffic. So
you're going to make the entire rest of the world do percentage.numerator instead of percentage so that you can specify we want 1/10,000th of this traffic.
Yes.
Am I understanding that right? That is not the right way to do this, dude. You know that's not the right way to do this.
No, I respectfully disagree.
I think Envoy has similar thing, isn't it? Like if you
I mean this is
translate it to Envoy config, it will be the same.
Fair. And so
Envoy config is deliberately not designed for humans to use. Remember that. My objection here is not that we should. I completely agree that we should support a way to say, I want to specify an arbitrary denominator for this fraction. 100% agree, think it's a great idea. My frustration here is solely that everybody who wants to use this feature, who wants to specify a percentage, we are going to force to specify an additional level of hierarchy because we're going to force them to say blah.numerator instead of just saying blah.
Why wouldn't you get
that's
a default?
Frustrating.
Why wouldn't you have it
already says the denominator is a default. So how are you going to set this up so that you don't have to how are you going to set this up so that you are not specifying an element in a structure instead of just specifying a percentage?
So here's my take. I don't think we could ever rule out having more precision. In this API, we do everything we can to leave room for further expansion. So you could imagine a world where we just launch with numerator or some value and then add room for more precision later, but that just seems awful and not particularly useful. But I also do want to time check here. As Arco said, let's leave comments on this gap, and I don't want to take too much because there's a lot more on the agenda still.
Let me be clear. Love the idea of the gap, and I totally understand that you may need fractions smaller than 1%. All right, onward.
Yep, cool. And the other gap that I want to call out here is backend MTLS. Marcin is on the call. He wrote this one up, which I really appreciate. I imagine there's going to be a lot of comments on this one. In my mind, this is non-controversial. We kind of left room for everything, hopefully, kind of, sort of. But I've already looked at this before this PR went out. So I have an idea of what's in here. Marcin, I don't know if you want to highlight any details. No pressure. If not.
Sure. So some surprising details are overrides. So we specify default client certificate on the gateway level, but we allow per service overrides. This might be a bit controversial, but the reasoning behind this is basically we sometimes have a software that has some specific requirements, specific certificates, or we want to explicitly disable MTLS for a given application. So that's the reasoning for the overrides. And I think, and another one is SPIFFE ID. So to support certificates that don't use DNS names, but use SPIFFE ID. As SNI doesn't support this, we will use different host name for SNI and different list of SPIFFE IDs, URIs, which are more generic for validation. So that's the other part that might be controversial. And the last one is to create, the last part is to create options for the backend TLS policy to allow implementation specific, passing implementation specific settings, like it's already available in the gateway. So that's like 3 parts of this.
Awesome. Thank you for getting this in here. I am looking forward to some reviews on this one and seeing what the rest of the community thinks.
Marcin, can I toss out one other thing to think about on that one, which is that
Sure.
if we're talking about MTLS with the intention of allowing the Ingress, the gateway controller and the mesh to interoperate in any meaningful way, I think we probably have to also explicitly talk about how you configure the CA trust bundle.
Mm-hmm.
I'm not sure what that looks like. I'm not sure how that fits in. I just wanted to kind of put that in your head as a thing I think we're gonna need from the beginning.
So for now, we were using the existing TLS trust bundles. And if we need to go deeper, that's I'm not aware of any specific requirements to address here. So is there any requirement? Mm-hmm.
I think it's fine to explicitly say, hey, this is the way trust bundles work if you do this, and just go from there. I think that it's a thing that should be present in some form from the beginning though.
1 minute.
Yeah, let's keep on running. We can have that conversation on the GEP itself. Candice, you've got a question?
Oh, I just had a question about whether we still need a GEP for TLS route, or whether we made a decision on the GEP for TLS route. Did you talk about that already, or?
Yeah, we talked about it a couple of weeks ago, and the decision was yes, we need it.
Okay.
Cool.
Thanks.
Okay.
I'll go through the other ones. Last time was, last minute cancellation. Just couldn't find anyone to actually run the meeting, and empty agenda. Lior was going to ask but dropped if we still have separate Gamma meetings. And yeah, Mike, thank you for answering that. There's also, Lior was going to ask about request header modification attached to backends. I haven't seen a ton of demand for that, but it is something that some support. So again, just I guess if anyone's interested in that, maybe raise an issue and we can help track whether there's interest.
What's needed there?
I think just understanding if anyone, no one's asked for it. That's it. Like, I don't think it's a very controversial thing to add. It's just no one has actually asked for anything there. So just even creating an issue to gauge interest would be, I think, step one. So to clarify, that's distinct from attaching at route level, which is what we do today already. And then maybe real quick, Dave, I think you've got the last one and we're at time. So if you can do that real quickly. Or maybe he's dropped. Okay,
I'm here,
either
yeah.
way.
Essentially, we never had any logic or language in the spec that says we should return non-500s, or specifically 500 status code. So it's kind of confusing. Like people reaching out like, hey, when I don't have any healthy backends, I'm returning a 500. And I'm like, that's a bit odd, given that I've seen every implementation return 503. So
yeah,
this kind of updates the spec to kind of allow implementations to return 503 if there's no healthy backends.
Yeah, thank you for catching this. I think this is, like you said, more representative of current state. I've already approved this myself after a couple rounds of feedback. I would appreciate an LGTM from someone else. Anyone on this call, if you want to jump in, take a look.
Took a look at this a year or so ago and reached the conclusion this was the right thing to do then.
Cool. Awesome.
Yeah.
All right. Well, thank you, everyone. I know we're past time.
Yeah.
Thank you.
Thank you, everybody.
Cool.
See you next time.
Thank you.